Hello everyone, I am Dharmender Kumar Chaudhary, Assistant Professor in Department of Textile Chemistry at MLVTEC Bhilwara. In our online lecture series of Theory of Dyeing, today we will discuss about the dyeing of cellulose fiber with basic dyeing. Before today video, we have already discussed about the some basic concept and properties of basic dyeing in one video. So now we will start about how to dye the cellulose fiber with basic dye. As all of you are aware that cellulose fiber like cotton do not have affinity towards the basic dye. So for any type of dyeing, there should be either affinity or there should be a process which facilitates the mechanical interaction of dye molecule inside the fiber structure, as like in polyester. So in case of dyeing of cellulose fiber, the second option cannot be feasible because the fiber is a natural type of a fiber and there is no thermal property like the polyester fiber. So here we need to develop the affinity of basic dye towards the cellulose. For affinity can be developed by pre-mordanting with tannic acid. Tannic acid is a type of mordant which is extensively used in mordanting process of cellulose fiber for dyeing of cellulose with basic dye. Tannic acid have OH group. So this the OH group which make hydrogen bond with the cellulose, while COH group in tannic acid react with the basic dye. In that fashion, tannic acid attached to cellulose as well as dyeing, basic dyeing in the further stage. Here we can see the molecular structure of the tannic acid. That OH group make hydrogen. That OH group make hydrogen bonds. This OH group and this OH group make hydrogen bonds with the cellulose fiber structure, and COH group in the next stage make attach to fiber. The COH group attached to the dye structure, because COH group it will give, now it will COH group CH is liberated, so there should be COO minus, that is negative anion. We can say anionic charge on this, and as you know, cationic dye, our basic dye have cationic charge on its colored portion. That's fashion it will attach to the fiber structure. Here you can see this is tannic acid molecule. This is OH molecule. When the cellulose is treated with tannic acid, it will make hydrogen bond with the cellulose. So by making hydrogen bond, it is attached towards the cellulose fiber. And after that, the tannic acid cellulose tannic acid complex is formed here. The cellulose tannic acid complex react with the basic dye. When we add the basic dye inside the structure, there is a cation and anion. This cation is a colored portion. So this cation is attached to the COO. We send the acidic COH group. H of this H is liberated and react with the Cl, form the Cl, and this cation of the dye is attached here. So in this fashion, the cationic dye can be attached to the cellulose by treating cellulose with tannic acid before dyeing process. This is tannic acid. So tannic acid act as a mordant for cellulose dyeing with basic dye. So this is cellulose tannic acid basic dye complex. As we know that tannic acid have property of the water solubility. So before after treating the cellulose with tannic acid, we need to fix the tannic acid by we need to fix the tannic acid with on the fiber structure or on the fiber surface or fiber surface, because it should not be removed after dyeing our in the further stages, because if it removed, then the washing fastness of the basic dyed cellulose fabric will be degraded. So now we will just discuss about the how we can do the mordanting process. So tannic acid have a capacity to deposit, capacity to absorb on fiber structure at lower temperature. That's why when we apply the tannic acid on the cellulose fabric, we can say that the mordanting process is starting at boil and then progressively reduce the temperature up to room temperature. Up to room temperature in 2 hours or more than that time, because as we reduce the temperature, the absorption of the tannic acid on cellulose surfaces increase. So to control this reaction, we can say the even deposition or the even absorption on cellulose fiber, we drop the temperature progressively up to room temperature. At that point, the maximum absorption of tannic acid is carried out. So fastness property of this type of dyed fabric is poor, because neither dye fiber reactions occurs, nor tannic acid basic dye complex is too bigger to develop excellent washing fastness. Tannic acid is water soluble, comes out in bath during dyeing, and so applied tannic acid is fixed on cellulose by treating tannic acid mordanted cellulose with tartar emetic to form a water insoluble big anionic complex. Generally, tannic acid used in double quantity of the dye quantity. Chemically, this tartar emetic is potassium antimony tartrate. Here you can see the chemical formula of the tartar emetics. So by treating the cellulose treated with tannic acid with tartar emetic, there is a water insoluble big anionic complex is formed, that is water insoluble. So we can say the problem of the degradation of the washing fastness due to removal of tannic acid from fabric surface can be avoided or can be minimized. So mordanting with tannic acid followed by tartar emetic is a long process. That's why there is a synthetic mordants are also developed where no fixing is required. Means there is no need to treat the pre-mordanted fabric with the tartar emetic to form a big anionic complex, because these synthetic mordants are not easily removed with during washing. So the dyeing process of basic dyeing of cellulose have three basic steps. That is, first is the mordanting. As we discussed, tannic acid, the solution of the tannic acid is prepared, and the cellulose fabric is treated with tannic acid, starting at boil and then cooling of bath progressively in 2 hours overnight, because maximum absorption takes place during cooling. Then after mordanting, we do the fixing. Fixing means the fixation of mordant on cellulose surface. So tannic acid treated cellulose is passed through the tartar emetic bath. Here the quantity of tartar emetic bath should be generally taken half of the tannic acid, and treat for 10 to 15 minutes at cold, followed by rinsing and hydroextraction. Then dyeing. Here now the mordanted fabric, the cellulose first treated with tannic acid and then fixed have affinity towards the basic dye. So the basic dye, so dyeing can be easily carried out here. Dye is pasted with acetic acid. Boiling water is added and stirred for a complete dissolution. Then dyeing is started at room temperature with addition of dye in installments, because there is a high affinity towards the cellulose. That's why to avoid the unlevelness or uneven dyeing, we add uneven dyeing of the fabric. We add the dyes in installment to control the exhaustion, and then raise the temperature at 70 degrees centigrade. Then dye pH of dye bar should be 4.5 to 5.5. We can say that there is a acidic pH. The pH of dye bar is acidic in nature in case of basic dyeing. So washing fastness can be improved by battening treatment. Battening treatment means the after dyeing, the dyed fabric is treated with the tannic acid to improve the washing fastness, but it altered the shade of the fabric. So generally this is avoided the battening treatment because of its negative impact on its shade. So in this way the cellulose fiber can be treated with the basic dyeing, just as we discussed. I would just summarize the steps and process of the basic dyeing of cellulose. First, for developing the affinity of basic dye towards the cellulose, we do mordanting. Mordanting means the treatment with the tannic acid, which have affinity towards the cellulose as well as basic dye. After mordanting, we fix the mordant, because if mordant is removed during washing, then the dye should go off from the fiber. So after mordanting followed by fixing, dyeing is carried out at 70 degrees centigrade in acidic pH. In this way, we can dye the cellulose with basic dye. Thank you very much. In the next video, we will discuss about dyeing of wool and silk fiber with basic dyeing.